Hello, my name is Max. I'm CTO and data scientist at Supervisely. And in today's tutorial, I will show you a very interesting experiment where we will train state-of-the-art semantic segmentation models in Supervisely. Sometimes it's really hard to manually label data. For example, if you want to segment cracks on surfaces like roads, concrete, or walls. And we did the following experiment. We generated synthetic training dataset and we managed to train the model that achieves comparable performance with the models trained on the real data. And right now I will show you how to do it. Let's start. Here is my Supervisely account. I have two projects. One project with synthetic data and another one with real test images. To train models in Supervisely, you need to connect your GPU machine. And to do that, you need to go to Team Cluster page, press Add button, and select Supervisely Agent. And here you will find a lot of video instructions how to do that. As you can see, I already have several computers connected to my account. Let's go back to the project. To start training, I need to go to Neural Networks page. I will use MMSegmentation app for training, and I need to click it from the context menu of the project. And in advanced settings, I need to select the computer with GPU I want to use for training. I will select this one and press Run button. Right now the application is started. Let's open it. We have several steps here. On the first step, the input project will be downloaded to the computer with GPU that will be used for training. Let's wait. The next step is to select train validation splits. We have several options here how to do that. My data is already split into train and validation, so I will do the splits based on the data sets in my project. For training, I will use these two data sets with synthetic images, and for validation, I have a small data set. I will select it. Let's create the splits. On the next step of our training dashboard, we have to select the class we want to use for training. And in our project, we have only one class of shape mask. So all cracks are labeled with the masks, and I will train the model to predict it. On the next step, we need to select augmentations. We have several templates here predefined, and also you can provide your custom augmentation pipeline. And for that reasons, in our ecosystem, you can find Image Augmentation Studio app where you can configure and visualize your augmentations. And then you can provide it here. I will use the default augmentations and I can preview them on real images if I click this button. So here they are. The image was slightly rotated and transformed, so the masks are preserved, everything is good, and we can move to the next step with using this template. By default, MMSegmentation toolbox provides a lot of different architectures with models. I prefer for this experiment to use segformer model. It's easy to train and it achieves very good performance. I will use this one, pre-trained on this data set, and we can go to the next step. The last step is to define training hyperparameters. When we integrate any toolbox from GitHub into Supervisely, we try to keep all original functionality as it is. It means that in our training dashboard, you configure almost the same settings that you can do from the source code, but in a more convenient way. As you can see, we have a lot of settings here. I will train the model 25 epochs with a batch size of 6. And also let's slightly modify the optimizer. I will keep learning rate by default, and I will change the loss function because in my experiment I have only one class. I mean, basically two classes, background and the target class, the crack. And for that purposes, I prefer to use dice loss. And let's also define the learning rate scheduler. I will activate it to work by epochs. I prefer to use step learning rate. Milestone will be 20 with the warm-up 1000 iterations. It means that first 1000 iterations, the learning rate will be slightly increased to the defined value. Then, after the epoch number 20, it will be decreased by 10. That's almost it. I also will decrease the weight decay here, and you can play with all these hyperparameters yourself and choose what works for you. I think I finished with the settings and we can finish the step. And the only thing I need to do is to press train button. So right now the training data will be prepared on the machine I connected to my account, and once the training process will be started, I will see the charts here in real time. Let's wait. As you can see, we see here the progress bar for epochs and for iterations inside an epoch. We also see here some training charts, learning rate, training loss, validation accuracies. Once the epoch will be finished, we will see here them, and some other metrics. Thus, we can monitor the training process in real time, and I think in about 20 minutes the training will be finished. We need to wait until the training will be finished. Then we will have access to our checkpoints and other training artifacts, and we will be able to deploy this model right inside the platform and apply it to our test data. As you can see, the training process is finished and all training artifacts are uploading right now back from the computer to the platform. The training process is finished, all artifacts are uploaded to team files, and the application is finished. So what we can do, we can right now open the training artifacts. We see here all information about the training, and we always can open the training dashboard at any time, and in the directory with checkpoints we'll find all our models, including the model with best accuracy. As you can see, it's from epoch 22. We can copy paste to this model and go to the neural network section. In the semantic segmentation tab, you will find we used right now the training app, and we also have an app in our ecosystem to deploy the model. To do that, you need to select the computer with GPU. I will select this one and press run button. The application right now is started. We see here a graphical user interface. I don't interested right now in running some pre-trained model. I will deploy my custom model. To do that, I need to paste to the checkpoint, select the device and press serve button. The model will be downloaded from team files to the machine and deployed. After that, we can send the request to the model, for example, from Python code, and get predictions back, or other applications from supervised ecosystem can communicate with this model. And I will show you right now how to apply this model to all images in our test dataset. So the model is deployed. Let's go to the list of projects. Let's run an inference app from the context menu of our test project. We have a special app for that, apply neural network to images project, and we just need to run it. The app is started and we can open. You need to connect to the deployed model. As a result, you see the basic information about it, the list of classes it produced. We just need cracks, we will ignore background. We can apply it to entire image or in a sliding window manner. And as you can see, here is an input image on the left and model predictions on the right. Let's apply this model to all our data. I just press this button and the new project will be created with all input images and model predictions. So the app is finished. Let's see the results. I can open them inside the labeling tool. Let me increase the opacity so it will be more visible for you, and I will go through the images and see model predictions. As you can see, model is quite accurate, and again it was trained completely on synthetic training dataset. It can segment cracks on different surfaces, and if you want to reproduce this tutorial, please follow the link in the description. There you will be able to find the training data and you will be able to find all details about the training setup. If you find this tutorial useful, please press the like button and subscribe to our channel to watch more computer vision tutorials with Supervisely. I encourage you to try this experiment yourself, and you can do that in our community edition. In case of any questions, you always can contact us. Feel free to do that. Have a nice day. See you. Goodbye.